Hey guys, welcome back to Ox Tools. I'm Tom. So Meatloaf 79 here. Got a bunch of stuff going on here. Just a reminder, we have the shop rendezvous coming up in next month, March 2nd and 3rd, 2015, not 2016. Mr. Bozo was doing some video editing on the the announcement for that event. So a couple of sharp-eyed viewers caught that and told me about it. So anyway, we got a viewer appreciation. Actually, it's a fellow YouTube creator, so we'll check that out. Got a flea market find, and I didn't even have to go to the flea market to find it. We've got some drill fixture tricks that we're going to show. Kind of a follow along to that saw base. We were using the tapping guide, but these are drilling guides, so we'll show some of that. We also have kind of an interesting tool that we're going to test, and it was loaned to me by power viewer Gordon Melby, and he's down in Arizona, and he sent this tool up, and we're going to do a test with it on the milling machine. That's kind of a neat thing. What else? I don't know. So let's go suit up and let's go see what's going on and see what trouble we can get into. Okay, so this is this week's hammers here, hammer acquisitions. So this one, let's do this one first. My wife went to the flea market on Sunday and texted me and said, "Hey, I found a hammer for you. I'm bringing it home." So here it is. It's actually a kind of a neat hammer, and I don't know, in the US we call this type kind of an engineer's hammer. I've seen them called that. Now this is a European one, and the reason I know that is it's marked 1,000 grams, and it's got a logo here. I'll come in closer and you guys can see the logo. I don't know, I don't recognize this maker. But I think it's relatively modern because it's got this molded handle protector, and that's just my general belief. It's pretty good. It's got a flat handle so that you can, as you're swinging, you can kind of orient with the world. You can kind of feel that, and it's got this nice protector to protect the upper edge of the handle. Handles get kind of narfed up along this area here. So anyway, she paid $6 for it, so I said, good deal. Anyway, how do you like that? That's a great wife for you. Brings home tools to you. You don't even have to go to the flea market yourself. So pretty cool. Now this one here, this is a, let me get the crane. This comes from a viewer. This is Eddie Kobus, and he emailed me and said that he wanted to make a hammer and send it into the show. And I said, sure, you know, hey, I'm not going to refuse a hammer, that's for sure. Well, this is what showed up in a flat rate box, so my mailman hates me right now. So I don't know, this is about, it's pushing 10 pounds here, I think. And got a big pipe handle here. So now, interestingly, Eddie has a YouTube channel that he's just firing up, so I'll put a little link up. You guys can go check it out, see the stuff he's working on. And I think he did a video of him, I saw him making the mold for this hammer. So he melted the aluminum out of cans to make a billet, a soup can billet, and then he machined that billet, and then poured the lead in there. So Eddie, thank you very much. This is an awesome hammer. This is I don't know, I'm getting kind of old to swing a big one like this. This is one of those ones you kind of hold at arm's length and you scoot stuff over and not lift it over your head or over your shoulder height. So and he's got some plastic dip on the handle for a little gription there. Eddie, thank you very much, and appreciate you sending something into the show. Guys, go check out his channel and see this hammer getting made. So now I got to find a slot in the rack for this baby here, so thanks a lot. All right, so here's the engineer's hammer, and there's the logo. I don't know if anybody recognizes that. It's some kind of stylized logo. I'm not sure if it's letters or what. And then you can see the weight there, 1,000 grams. So, and you can see that's interesting that they it's kind of a rubberized potting in there, that maybe they glued the handle in there or potted the handle in there with something. So, pretty cool. Okay, so here's this tool that Gordon Melby sent us, and I'll give you a peek at the label on the box there. And what we got here is we have I call these spindle speeders, and what these are, they're speed increasers. This particular one's set up for an R8 spindle, and then it has a collet. The ability to take a collet in here to hold an end mill or a drill or something like that. So actually, let's pull this out of here. I'm going to set this off to the side a little bit. So the way it works is it's got probably a planetary gear setup in there. And we'll stick this in just because it's going to make it easier for me to hold on to. So as I turn this, as I turn the R8, I get an output out of here. Now this is a reaction arm here that you have to put up against something. And this particular one is a 7-to-1 ratio. So for every single turn of the R8 spindle, okay, I get 7 turns out of that. So it's a speed increaser. So let's see. I can't remember what the top speed of my mill is. You know what? I'd have to go look. I can't remember. But anyway, it gives you the ability to get pretty high RPM. So if I can get 4,000 out of my milling machine, I can get 28,000 out of this. All right, 4 times 7, right? So that's almost 30,000 RPM. So I don't know what this thing is actually rated for. A lot of them are rated for less than that. And you know, we used to have one of these at one of our shops, and so you look at it and you go, oh, hey, if I put 10,000 in, I can get, you know, 70,000 out. Well, they have a speed limit, and I don't know what the speed limit is on this one here. Now, Gordon graciously loaned this to me for testing, and we're gonna go try it out on the mill here in a bit. And let's take a look at some of the accessories. I'm going to change the camera a little bit, and then we'll come in and look at some of the accessories. Okay, so it's got a couple wrenches for doing tightening the collet up, and then it has some collets. And one of the collets, you know, when I took it out of the box, Gordon, this particular collet was broken. It was loose, floating around in here. Actually, there was a few things that were kind of loose floating around in here. So I don't know if this was broken before or if it got broken in transit. Now, it looks like there was 4 sizes here, and of the 4 sizes that could break, this would be the one that I'd want to break if I really wanted to break one. This is 3/16, which is, you know, sure, it's a useful size, but the 1/8 and the 1/4 inch are the ones you really need. This 5/16 here, and then there's a 3/8 that's in it. So if you're going to break one, this would be the one to break here, in my opinion, because, you know, when you get into the small carbide end mills, they're usually 1/8 shank. 1/4 inch is real common, and I think was that 3/8 or 5/16? I don't remember now. Yeah, 5/16. So anyway, that one's busted. You know, it's not a real complicated collet, and you can see here the little. This is all that was kind of holding the whole mess together. Is that tiny little flexure there? So pretty easy to break there. So, and it's all heat treated. Now the other interesting thing that's in here is this guy, and this is the collet taper here. But then this is a #1 Jacobs taper, so you can put a small chuck on here. So I'll poke around a little bit and see if I have one that has a number 1 Jacobs taper on it. So let's go over to the mill and let's give this thing a spin and see how it behaves. Okay, so we got this thing up in here, and I just noticed the part number here, X7G, so that probably means the 7-to-1 ratio. So let's put the reaction arm in. Give that a little grunk, okay. And then I got this fits in this little indicator arm over here, or this casting on the side of the mill. And that'll be our reaction arm. Okay, and then I can still slide on that, just I can't go past that, so I could drill with that. Okay, and so I got a pin, the gauge pin, and then the 1/4-inch collet here, and I thought we'd check a little, check the run out on this thing, and then maybe try milling something with it and see how it behaves. Well, let's just do that. Okay, stick that in and leave that hanging out about 25 millimeters, something like that. Okay. And for once, so both of these wrenches are 23 millimeters, so somebody was thinking ahead a little bit. They made these both the same size, because in many setups like this, one is one size and one is another, and it's pretty, let's just say, aggravating. Okay, so all right, let's get an indicator going here. We're going to use our little R8 base here, which actually just kind of snaps on there nicely. All right. Get up here. I got our little Noga arm here, and what I'm going to do is I'll just get it kind of close here, and then I'm just going to rotate it in until it. Let's do that. Can't have you guys. Can you read that? Yeah. Okay. Kind of see that. Oops. Rotate that in until we get close to 0. All right. Not bad. Okay. So let me get up on my little step stool here, and I'll. Come on, you little bugger. Okay, there it goes. Oh, duh, I wanted in neutral, not in gear. All right, well, what is that? Zero. I don't know, I'm seeing up almost 1,000, 9, 10, oop. It's hard to back up here. Alright. Kind of bouncing around a little bit there. So that's a shade over 1,000 there, which for milling is not terrible, but for drilling with small drills, that's not good. Generally, with small drills, you're looking for your run out to be a very low percentage of the diameter of the drill. 1 thou run out on a 10 thou drill is not good, but 1 thou run out on a 1/2 inch drill, nobody cares about. Small drills are very, very sensitive to being on axis there. So let's go up a little bit. Maybe that's part of our problem here. Let's try that. Okay, spin that little monkey. It's kind of interesting. It's kind of, I wonder if it's. It doesn't seem to be doing anything there. It's got a little lumpy lump to it there, a lobing or something. I don't know. But that's still showing 1,000 up that close. Let's actually let's do this. Let's get this out of the way for a sec. Let's take this out. I did wipe that out of there before I did all that, but let's put an indicator on the inside of that and see what we get. Let me turn this so you guys can see this thing. Oh, hey, I could just move the table. Let's do that. All right, let's give that up. Let's see, make sure that's tight. You know what? I need to cut down a little bit there. I was kind of right on the corner there. Let's see, can you guys see that thing? Yeah. Kind of oblique angle there. Oh, let's get up against that. It's kind of bumpy actually. It's about 1 thou, even on the inside of the collet surface, which means it's probably not the collet itself that's causing the run out here. The camera moved a little bit. It's on a wheeled stand, and maybe you guys can see that indicator a little better now, but we got upwards of 1 thou there, which is kind of a lot actually for the collet mating surface. Usually the problems are in the collets with things like this, but in this case, this one's running out a little bit. Well, that is really not going to stop us from trying this thing. So let me find, let's see, I got 1/4 inch in there. Sure, let's do 1/4 inch. And let me get an end mill, and then we'll get a little test victim, and we'll do a little milling. Okay, so we got a little chunk of aluminum here with some liquid love on that. And so let's try starting out at that's 1,000 RPM on the spindle. The main spindles, which should be 7,000 there. Well, let's see what we got here. See how it behaves. Like I said, I see this arm, there's a little bit of torque on that arm, not much, but it's kind of bouncing against that, which is, I don't really like, but let's see what happens here. And part of my instinct says to hold on to this, but keep it steady against there. Alright, let's go in a little bit. Doesn't sound that great, but yeah, it's kind of chattery. I don't know. I mean, that's kind of basic stuff there. So let's see here. Let's try a little slower. 500, that's half of that. So that's, I don't know what, 3,500 there. Approximate, oh, let me take a little cut here. feeding it pretty hard coming across. That's, let's get the record player going there. I don't know. I'm not getting real excited here. Let's do it again. I'm going to take a couple of thou. I won't go back across it this time, just so we get a look at the finish it's leaving there. So. Go back here so we can look at that. Okay, that's better. Still not wonderful. Now, you know, this is a used tool. Maybe that's part of it, but I think there's, you know, the run out in this scene, there's a little bit of vibration. You just got more stuff going on here too. So, let's see, what else can we try? Maybe I'll try a smaller end mill, and we'll, I'll get an 1/8 inch shank end mill, and then we'll give that a go and do something that really kind of needs the higher speed there. So, okay, so we got a little ball end mill in there. Put a little juice on there, and let's give this thing a go here. Actually, yeah. So I can quantify this. I'm just going to zero the quill readout so I kind of know where I am. So let's go in about 10 thousandths there. Okay. And go back up about so that's 7,000 on the output. The chips look excellent here. Let's see what we got. So the chips are, the chips look really good on that. Oh yeah. Oh yeah, can you guys see that pretty well? Yeah, you can see that pretty well. All right, so in the little end mill, looks like it's working pretty good. So let's keep going on that. I'm going to drop down, this is 1/2 millimeter here, depth of cut. Oh yeah, the chips look real nice. They're separating and they're shiny, so. Not the quietest thing around. Oh yeah, finish looks really good down in there. So yeah, that works good on the little end mills. So maybe it just doesn't like the larger tools, which kind of makes sense. There's just, you know, you just need more rigidity the larger the tool that you have. So that's pretty good. I like that. Okay. Let's see. Let me check the viewfinder here. Yeah, you guys can kind of see that. Okay. All right, I don't know. Let's see. Let me think of something else here. Maybe we'll try. Now that's a ball end mill too, which, as you guys know, at the bottom of the ball, at the center of the ball, the velocity is actually 0. So it's always very difficult to get a nice finish in the bottom of a full round channel like that. So there's usually a little witness line down the middle of it where the tip of the ball is just kind of smearing as it goes along, and this doesn't have any of that. So, or if it does, it's very tiny. It looks pretty small. So, cool. I like that. Okay, so I changed the end mill. This is a flat end mill, 1/8 diameter, a little over 3 millimeters, and we'll do a cut with this one too, and I think I'm going to go about 3 millimeters deep. Let's just give it a go and see what happens here. It's 100 thousandths deep. Put some juice on there, and we're still running at our 7,000 RPM output here, so see what we got here. Yeah, it's making a little noise this time. Let's see what the finish looks like there. It's kind of hard to see. Let's see, what do I want to do with that? Let's try half of that depth of cut. So this will be a little over a millimeter here, 50 thousandths. Let's try that, see if that makes a difference. Same thing. Ooh, yeah, watch out for that. I'm gonna clobber my camera there. So I hit the, I don't know if you could see that. You couldn't see that, but when I hit the brake, the reaction arm swung around, which kind of alarmed me slightly. I don't know, it's not bad, but it's, yeah, it's got some, I don't know, you probably can't see that with my light. It's got some chatter on the wall, on the vertical wall here. There's a little bit of chatter on that. So, I don't know, stuff smaller than 1/8 of an inch is probably pretty good. You know, with a thou run out in this thing, this probably needs to be taken apart and cleaned and kind of gone through. And maybe we'll do that. I'll talk to Gordon and see what he wants to do on that, and then we'll go from there. Anyway, thanks for watching, guys. That was kind of fun to play with that. All right, so you guys have seen me use these tapping blocks that have holes through them. This one's a little different. It's along the same lines, but this is a drilling block here, and it's kind of set up with these removable drill bushings. So it's got some fixed liners here, and then this particular one's tight, but it's got the liners pressed in. So that one's a 1/2 inch, 5/16, and 3/4. And then these other smaller ones will fit in, and that's 1/4 inch inside. That one's 5/32 inside. And I can put a bunch of different ones in here. That's 3/8. And then this one here is the one we're going to use, is 27/64, which is the tap drill for 1/2 inch. Okay, so I've already drilled one. I'll go ahead and show another one here. And I just line this up in my center punch mark there with a transfer punch like that. Okay, I'll put a clampicus on there, like so. Okay, that comes out. Then we can drill, and it keeps everything nice and perpendicular to the universe there. And then because it's a drill bushing, you'll have to clear the chip a little bit to make sure you're getting them out. Oops, still need that. So this is an easy drill to push for a pilot drill. Okay, so oops. break off, huh? Oh, probably come out easy. Yeah, see, I didn't back out soon enough. All right, let me get another drill. Well, how do you like that? Okay, I got to go find another drill. All right, so got another drill. At least I had one. All right, let's finish this hole off here. So I'm going to clear the chips a little more often. I think I packed the chips in there, is what I did on that last one. And just to kind of put it in perspective, you can't really see how fast I'm moving there, but that's how far in I am already, right? So the difference between the aluminum plate and my thumb. So I'm in there an inch already. I don't know if, this high-speed drill and being able to lean on it pretty good make for pretty quick drilling. So. Okay. So this might be close to my last one around here, so I gotta. All right, that's probably deep enough for what we're doing here. All right, and so then I'm going to show you another trick with the larger drill here when we go in to do the larger hole. So it's kind of an interesting thing that I learned a long time ago, but had to use it recently at work and thought I would share it with you guys. So let me get that all set up and we'll see if we can get into some trouble with that. All right, you guys ready for this? So I drilled one and I'm going to drill this one now. So we're going to use our 27/64 tap drill for half 13, and I'm going to use a transfer punch to line this up. So this is our pilot hole here. Okay, we'll go in the pilot hole. Okay, and then we're going to C-clamp this nice and secure, like so. And what this next thing's about is, if you've ever had to drill a bunch of holes in the field in steel or something crazy like this, it's pretty tiring actually. And you need, if you're lucky enough to have a magnetic drill, that's, certainly the way to go, but that's not always the case. Sometimes you're working at a disadvantage. So here's a way to get a little advantage. You'll see I got a motorcycle tie down, but this could be a chain, just basically something to resist the force. So, okay. All right, this one, I use this because it's kind of easy to adjust. And let me show you the main principle here. So here's our drill going into our drill bushing, and it's in our pilot. So normally you'd be here and you'd be leaning on this to push this down, and you can see that it's kind of in an awkward position for me, just standing here. So what I have is I have this bar here, and it's got a hook in it, and then it's got a little swell in it here that let's see, let me make sure you can see the top of the drill there. Oh, you know what? You can't see the top of the drill. Let me reframe the shot a little bit, and we can see the whole setup here and better understand what we're doing here. Okay, so this frames this shot a little bit better. So here's our restraint here, and then here's our hook, and that goes through here, and I need to adjust this a little bit. So you get this to where you get a little bit of leverage, and I can pull this one down like that. So now I can lean on this drill pretty hard. Now, warning, this is not for the faint of heart. This is a little squirrely, okay? It actually works better when you have two people, one to kind of control the drill and one to add a little bit of pressure, because they can listen to what's going on with the drill, and this guy can say, hey, ease up, or whatever. Because you end up having to hold the drill with one hand. Now you'll see that it works, and so let's go for it. I'm lined up, and I'm just going to go. And what I want to do is I want to hold the drill on this side here, And the reason is that if it bites and catches, it's going to rotate this way, and it's going to rotate out of my hand, not into my hand, okay? So that's kind of an important thing. So it's like a little, I don't know, safety measure or whatever, so that if something starts to go south and you kind of let go, it's going away from you, okay? All right, let's go for it here. All right, then I'll take up on this a little bit. Okay, now I need to clear the chips now. Let me just set that down. And we come out. All right, and I'll blow the hole out. Okay. And rinse and repeat, actually. And you can see that fits pretty good there. All right. And I'm not working very hard here. Okay, and I can feel it when the bushings start to pack. Okay, so we're well over an inch deep now. Okay, and that's a pretty big drill to push by hand. So it's just giving us a little mechanical advantage, okay? And it's kind of easy to set up. I think I'm at the bottom of the hole now because the pressure went up, or it got smooth, I should say. Like there was no more pilot hole. And you see, I'm wearing gloves, okay, and with good reason, because I'm pulling on this, you know, and I'm sliding along the flutes, and it just protects me, okay. I'm well away from the rotating bits here, okay. So that's it. That hole is full depth now. Okay, and now we can just chamfer them and tap them. Done deal. Okay, done.